Good day once again, ladies and gentlemen, and this time we are going to be looking at acids and bases. If you have not subscribed, please just make sure you're part of the family. All right, so let's look at this question quickly. Now, we'll not start, unlike the other questions, right from the beginning, because I think the real gist of this question is right at the end. So I think you could do quite well with the first portion. So they say to us in 7.3, a school laboratory has a hydrochloric acid solution, right, with a concentration of 1 mole per cubic decimeters, right? And they want us to calculate the pH. Of course, I know you could calculate that quite well. Now, what you just need to remember, ladies and gents, is that, okay, please remember, once you're given hydrochloric acid, remember that the concentration, or rather the formula for pH, is minus the log of the hydronium ion, right? Now remember, we don't have the concentration of the hydronium ions. We've got the concentration of hydrochloric acid. But what do we know? We know that hydrochloric acid ionizes in such a way that it will form only 1 mole of hydronium ion for every 1 mole of H3O plus Cl minus, 1 mole of hydrochloric acid will form 1 mole of hydronium ions. So which means the concentration of hydrochloric acid should be the same as that of hydronium ions, right? Please be careful if it's sulfuric acid, that would be different, because it means that you'd form, for every 1 mole of sulfuric acid, you'll form 2 moles of hydronium ions. So in this particular case, it means that the concentration should be the same as that of the hydrochloric acid. So that's minus the log of 1, and that pH will be 0. Okay. Of course, we know that for acids it's from 0 to 7, so that still tells us that it is an acidic solution, right? Okay, and secondly, they say to us, calculate the number of moles of hydrochloric acid in 250 cubic centimeter solution. Right, so for 7.3.2, we want the number of moles, so we know concentration is number of moles over volume, so that means number of moles is concentration times volume, right? Our concentration is 1 mole per cubic decimeters. Our volume in this case is 250 cubic centimeters, but we need to convert it to cubic decimeters, so we divide by 1,000, so that will be 0.25. So remember, that's 250 over 1,000. That gives us 0.25, and that's where we get that there, right? So which means the number of moles of hydrochloric acid initially will be 0.25 moles. All right, so there it is there, right? And then now they say to us the eggshells contain 99.3% of calcium carbonate, right, by mass. And they say the calcium carbonate in the eggshell reacts with excess hydrochloric acid according to the balanced equation below. Right, so they say to us, so if you look at it, we know that calcium carbonate reacts with hydrochloric acid. So in the eggshells, it's only 99.3% that is the actual calcium carbonate, right? So they say the unreacted hydrochloric acid is neutralized by 103 cubic centimeters of sodium hydroxide, right, and of 0.5 moles per cubic decimeters. Okay, now what would have happened in this case? All right, I've got this on reserve just in case we need it. Okay, so in this particular case, you would have the amount of acid. You remember we had 0.25 moles of hydrochloric acid, right? Now, what you're going to do is you're going to use some of this acid to react with the eggshells. So let's say we've broken down the eggshells, and we pour some of this acid in there. Okay, And what we then realize is that not all of the acid actually reacts with the eggshells, right? So meaning that at the end of the reaction, there is some acid that is still left, okay? So this is going to be the excess acid, right? And then in this case, we're now going to take the excess acid and we're going to react it with sodium hydroxide, okay? So the excess acid, we take it and we react it with sodium hydroxide. Now they gave us the concentration of sodium hydroxide and they gave us the volume of the sodium hydroxide. So what I'm going to do is they gave me this guy to be 0.5 moles per cubic decimeters, and they gave me the volume to be 103 cubic centimeters, right? Now you agree with me, we would be able to calculate the number of moles of this sodium hydroxide. And of course, remember they reacted completely with each other with the excess acid. So I can use stoichiometry to find out how much the excess acid is, all right? So let's do that first of all. So I'm going to find out the number of moles of sodium hydroxide. Okay, that's concentration times volume. So that's 0.5 multiplied by, remember we convert that to cubic decimeters. So we're going to divide by 1,000 again. So that will give us 0.103, right? So let's calculate that quickly. Okay, so that's 0.5 times... So 0.5 times 0.103, that gives us 0.5, 0.0515 moles, right? So now we know that they react in a 1-to-1 mole ratio. So for every one there's one. So it means for every number of moles of hydrochloric acid, therefore the number of moles of hydrochloric acid in excess will also be 0.0515 moles, right? And why is that? Because it is a 1:1 ratio. Of course, if in this case you had a 2:1 ratio, we would apply that accordingly, right? Now, ladies and gents, I want you to please note, we've got the number of moles of hydrochloric acid in excess, but where does the excess moles come from? We started with the initial moles of hydrochloric acid, but remember, there's the reacted moles. So the reacted moles are the ones that reacted with the sodium, with the eggshells, right? So we know that the excess, which is 0.0515, apologies about that. Okay, let's write that nicely. 0.0515, right? Our initial moles in this case were the ones that we got right from the beginning, 0.25. Okay, so we know that we started with 0.25 moles. So this will be able to give us the amount of hydrochloric acid that would have reacted with the eggshells, right? So the number of moles that reacted, okay, so we're going to take 0.25. Of course, you know, if you do your gymnastics, you'll see 0.25 minus 0.0515, and that will give us the number of moles as 0.198, 0.1985. Okay, I'm just going to keep all of those decimals just for the sake of accuracy, right? So now I'm looking for the amount of eggshells that, you know, in this case, they wanted the mass of the eggshells, right? So remember, they've already given me a percentage purity, right? Now, What did the hydrochloric acid react with? It reacted with the calcium carbonate in the eggshells. So let me find out the mass of calcium carbonate in the eggshells, right? So I'm going to look at the reaction of the eggshells, or rather of the calcium carbonate. For every 1 mole of calcium carbonate, I get 2 moles of hydrochloric acid. Can you see that? So I'm going to say, right, for every 1 mole of calcium carbonate, I get 2 moles of hydrochloric acid, right? So the question is, for how many moles of calcium carbonate will I therefore get 0.1985 moles of hydrochloric acid? So I'm looking for the number of moles of calcium carbonate. So I take the coefficients. 2 times n will give me 2n, and 1 times 0.1985 will give me 0.1985. And if we divide that by 2, okay, the number of moles of calcium, pure calcium carbonate, the one that reacted with the acid, okay, so I'm going to take that answer and divide it by 2. I get 0.9925 moles. So that's the number of moles of calcium carbonate. Now, I want you to keep in mind, ladies and gents, and this is where our periodic table comes in, right? So number of moles, I'm looking for the mass of the pure calcium carbonate, right? So the number of moles is mass over the molar mass. I'm looking for the mass in this case, so mass would be number of moles multiplied by molar mass. I've got 0.9925, right? And calcium carbonate, remember, there's our calcium over there, right? Right, with the mass of 40. Okay, so there it is. Okay, maybe let me just try and increase the size of this, right? So our calcium, there it is over there. It is 40, carbon is 12, oxygen is 16, right? So calcium carbonate, that's carbon which is 40 plus carbon which is 12 plus 3 oxygens, 3 times 16, okay? In this case, that would give us the amount of calcium carbonate, right? So I am going to simply say, right, what is the mass of calcium carbonate? Okay, so if I take that and I multiply it by 100, okay, so that gives me 9.925 grams. So in the eggshells, the mass of the pure calcium carbonate, right, was 9.925. But I want the mass of the actual eggshells, right? Remember, the eggshells are made out of the pure calcium carbonate plus, the other impurities or the other stuff. Okay, so in this case, remember when we calculate percentage purity, right, we always say the mass of the pure divided by the mass of the impure, all right, and we multiply that by 100. Okay, right, but they've given us the percentage purity. They said this is 99.3 if I remember. Okay, yeah, it is. So that's 99.3, right? We've got the mass of the pure, which is 9.925, okay, over, now we're looking for the mass of the impure, so meaning the total mass, right? And in this case, multiplied by 100. Of course, we can divide by 100 on both sides, okay? All right, that cancels with that. And in this case, to get the mass of the pure, okay, so I'm going to say and 99.3, so this will give us 0.993 is equal to 9.925 over the mass of the impure. Okay, over mass of the impure, or we can say the total mass. Of course, ladies and gents, it goes without saying here, right? We're just simply going to cross multiply. Okay, so the mass of the impure calcium carbonate would be equal to 9.925, and let's divide that by 0.993. Okay, right, so I think the total mass of it will actually be 10 grams, right? So let's just round it off to 10 grams. It would be 9.99, but we can round that off to 10 grams. So that was the pure stuff that eggshells are made out of. All right. So I hope that you understood that question, ladies and gents. And of course, please do best. When it comes to acids and bases, if you understand this portion, I think it will really make a huge difference. Okay, please strive towards this portion, okay, in these 8-mark questions. Otherwise, ladies and gents, I'll see you guys next time. Sharp, sharp.